Hi. So we're now going to talk about piecewise defined functions and one-sided limits. Actually, you could take one-sided limits with functions that are not piecewise defined, but the function that we're looking at in your notes happens to be a piecewise defined function, so we'll look at that. And what does it mean to be piecewise defined? It means that the function's defined different ways on different parts of the number line on its domain. So in this first piece, in this first section, for values of x that are less than or equal to -5, this function is 0. So when we look at the graph, that would just be this piece. So over here, this would be x equal to -5. And for anything less than or equal to, so actually -5 is mapped to 0. That point is the ordered pair -5, 0. -5 gets mapped to 0 under this function. Now for x strictly between -5 and +5, this function has this this representation, and that representation, maybe you recognize that that's actually a half circle. That's the positive half of a circle. That circle would be a circle centered at 0 with a radius of 5, because that circle would satisfy x squared plus y squared equal to 5 squared. So if you solve for y here, y would be equal to plus or minus the square root of 25 minus x squared, right? So the positive half of that is here. Now it doesn't look like a circle because of the way the window is set in the calculator, so it's just distortion. It's a distortion of the image, but really that's supposed to be a half circle. And when x is equal to +5, this that point is not on this circle. So really, it's you could represent that with an open circle at this end. And that's true on the left side as well. That point's not included, but in fact, when x is -5, y would be 0, and that's how this function is defined. So from the half circle point of view, it's an open circle, but then from where the function is defined as 0 at x less than or equal to -5, that hollow circle is filled in. So on the left side, there's no gap or hole or break, but on the right side there is, because +5 is not actually mapped to 0. +5, you can see from this last part of the function, +5 gets mapped to 3x. So +5 gets mapped to 15. So this point is the ordered pair 5, 15. So f of 5 is 15, and then for all values of x larger than +5, they're mapped to that part of the graph. So the first thing I wanted you to think about is actually what this function looks like, and the way you graph this function. I have that the details of that the screenshot of what you need in your calculator is there. So now we'll look at some of these one-sided limits. Now in the first case, we're looking at the limit as x approaches -5 from below. Okay, so if x is approaching -5 from below, that means, well, let's see, this is x equal to -5 here, and we're approaching -5 from below 5. So that would be, those values of x are mapped here on the graph. Okay, and so as we get very close to -5 but are strictly less than -5, all those points get mapped to 0. So as close as we get to -5 but not equal to -5, all those values of y are 0. So this limit is 0. Now, if we look at the limit as x approaches negative 5 from above, we're approaching negative 5 from the right, and the image of those values are on the half circle. So those would be here, here, here. As we get closer to negative 5, but strictly larger than negative 5, we're getting as close as you want to y equal to 0. Okay, so the limit as x approaches 5 from above is also 0. Now, we want to, now since we have, well, this is the lower limit. This is called the upper limit. And since we know the lower and the upper limit, and those are both equal to 0, we can then say the limit as x approaches negative 5, that's equal to 0. Now we'll look at the lower and upper limit as x approaches positive 5. So here's the lower limit, and we know that by this little minus sign that's here. So this is limit x approaches 5 from below, or the lower limit, and this one is limit x approaches 5 from above. That's what that little plus sign indicates. That's an upper limit. So in those cases, the lower limit, we're approaching positive 5 from below 5, from values of x that are smaller than 5. And those values of x that are smaller than 5, if we look at the image of those points under f, we would see that those points are mapped to this part of the half circle, and those y values get smaller and smaller and smaller, and those will get as close to 0 as we want. So if we take a value of x that's sufficiently close to positive 5 but strictly smaller, say like 4.999, and look at the image of that point under f of x, for x equal to, say, 4.999, we would be at this part of the function, and 25 minus 4.9999 squared is going to be a value that's really close to 0, but strictly positive, and when we take the square root of that, we'll get a value that's strictly positive, but very, very close to 0. So this this lower limit is equal to 0. Okay, now what about if we look at the upper limit? We're looking at the limit as x approaches 5 from above, in other words, from values that are strictly larger than 5. What happens to the image of those values? Well, if x is larger than 5, we're looking at this part of the graph. And all of those values for x larger than 5 are mapped on this, this line. And so as x gets close to 5 but strictly larger than 5, those values will get as close to 15 as we want. So the limit as x approaches 5 but from above, that's 15. So here, in this case, we see that the lower and the upper limits, these are not equal. And since those are not equal, that means that the limit as x approaches 5, that doesn't exist. Does not exist. It fails to exist because the lower and upper limits are not equal to each other. In other words, we can't get within a very close, if we get within a very close neighborhood of x equal to 5, there's not a single value of y that we would get mapped into, because in the lower end we're near 0, and in the upper side we're near 15. So the limit as x approaches 5 fails to exist.